Delegati, colleghi, cari amici, buongiorno. Good morning, ladies and gentlemen, dear delegates, dear colleagues and friends. I'm Maria Teresa Orlando, and it's my great pleasure and honor to welcome you here in the Neutral Beam Test Facility in Padova for the celebration and inauguration of SPIDER, the most powerful ion source in the world. SPIDER, the sleeping beauty, is right here in my back, behind this concrete wall. And if all goes well, we'll soon be able to wake it up and bring it to life. So you can understand it's a very strong moment, an emotional moment. And, all here are very, anxious and nervous about that. Not only me, but also everybody who has participated in the construction of this facility and this fantastic machine. And, everything here is ready. All people are nervous. The people who will be on stage right soon performing their role here, but also people in the control room where they are ready to get the go ahead to the procedure. This is a very particular moment, and if something goes wrong or there are some glitches in the today's program, please forgive us. We are not actors. Here, there are only scientists. But however, I am really sure, and I hope, we will be able to welcome you here very well and to make of this day a special day on our quest to fusion energy. Thank you. thank you with the music. I now invite Francesco Gnesotto, President of RFX, to officially open the ceremony.
Dear Director General of the ITER organization, Bernard Bigot, dear representative of the Italian Ministry for Education, Universities and Research, Salvatore La Rosa, dear member of the European Parliament, Flavio Zanonato, dear representative of the DG Energy of the European Commission, Carles de Deu y Fontcuberta, dear Councillor for Public Works and Infrastructures of the Veneto region, Elisa De Berti, dear Rector of the Padova University, Professor Rosario Rizzuto, dear Director of Fusion for Energy, Johannes Schwemmer, dear representative of ITER India, Chandramouli Rotti, distinguished guests, ladies and gentlemen. It's a pleasure and an honor for me to welcome you all at this ceremony for the inauguration of the Spider experiment, and I warmly thank all of you for your presence today. Exactly 5 years ago, on the 13th of June 2013, we started the erection work for this new laboratory, totally financed by the National Ministry for Education, University and Research. And I take this occasion to thank its representative for that. In 2015, we started the installation of the experimental equipment, totally financed and procured by the European, the Japanese and the Indian agencies for ITER. Thanks a lot also to them for providing, through the best industrial companies of the relevant countries, this huge system at the real forefront of available technology and sometimes also beyond. Maria Teresa Orlando already presented you the people who played and will also play in the future the key scientific and technical roles for this facility. Without their continuing commitment and their solid competence, all what you can see here and will see much better during the visit in the afternoon would not have been possible. I still ask you another big applause for them. And we should not forget the invaluable contribution also by our technical and administrative services. But today, I would also like to recognize the fundamental role played since the foundation of Consorzio RFX in 1996 by the partners of the consortium, the 4 founders, the National Research Council of Italy, CNR, the University of Padova, the Italian National Agency for New Technologies, Energy and Sustainable Economic Development, ENEA, and Acciaierie Venete, our private partner. Plus the National Institute for Nuclear Physics, who joined in 2005, exactly at the start of this new big adventure with the ITER neutral beam injectors. The synergies made possible by establishing the consortium have created a frame in which a challenging enterprise like this may work and progress. So my warmest thanks go to our partners. Unfortunately, the presidents of CNR, ENEA and INFN were not able to come today. Nevertheless, they are well represented here, and I'm proud to have here with us the rector of our university, who is representing all the partners. I am really grateful for him for being here, particularly since he has just come back from a mission in the United States. Well, as you have seen in the invitation, we organized this ceremony to celebrate the inauguration of the Spider experiment. whose installation and commissioning have been recently completed. For us, and certainly also for ITER, it is an important milestone after several years of very hard work. But in the last weeks, my colleagues who sit in the rows behind you have even multiplied their effort to try to really start today the new phase of our job. I don't want to enter into technical details now. The director of RFX and the project leader of the neutral beam test facility will tell you something later on. But I'd like to tell you that we will really try today, in a few minutes, to start operation of SPIDER in front of you by producing the first plasma in the ion source. Everything is ready. Let's cross fingers and please have a little patience. As I told you, Consorzio RFX is the outcome of the joint effort of our 5 partners, but it is strongly rooted in our city of Padova, which, by the way, is not new to such scientific enterprises. So the moment has come to leave the floor to the mayor of the city of Padova, Sergio Giordani. Thank you very much, Sergio, for having accepted our invitation. Please.
Signore, signori, buongiorno. È con grande piacere che porgo il saluto da parte della città di Padova e mio personale a tutti voi, che rappresentate i partner italiani e stranieri coinvolti nel progetto ITER.
It's a great pleasure to greet you on behalf of myself and Padova City, to you who represent Italian and foreigner partners involved in ITER project.
Qui oggi, presso questi laboratori del Consorzio RFX, diamo via l'esperimento SPIDER, che ha un'importanza fondamentale per il percorso scientifico e tecnologico che tutti ci auguriamo porterà verso la produzione di energia da fusione e quindi alla possibilità di disporre di elettricità in modo sicuro e compatibile con l'ambiente.
Today we start the SPIDER experiment here at Consorzio RFX. SPIDER has a fundamental importance in the scientific and technological route and all of us wish that it will lead to the energy production from fusion and hence to the possibility of electricity available in a safe and environmentally safe way.
Lasciatemi dire che per noi oggi è un orgoglio che questo passo si compia qui in questi laboratori prestigiosi, che sono parte di una rete internazionale di ricerca di altissimo livello.
Let me say that we are proud that today we have this step forward in a prestigious laboratories which is part of an international network of research of high level.
Lo dobbiamo alla capacità degli scienziati che qui operano da anni, agli ingegneri che hanno progettato i macchinari necessari alla realizzazione di questo esperimento e le industrie che li hanno realizzati.
We owe this to the capacity of the scientists who work here since years, to the engineers who designed the equipment necessary to the realization of this experiment, and to the industries which realized them.
L'Italia ha un ruolo di primo piano a livello internazionale nella ricerca sulla fusione, sia per quanto riguarda l'ingegneria, sia per la fisica, e offre opportunità importanti di investimento su progetti solidi e tecnologie di avanguardia.
Italy has a first role at international level on fusion research, both concerning the engineers and physics, and offers important opportunities of investment on solid projects and cutting-edge technologies.
Con la sua università, il cui costante lavoro di ricerca ha significative ricadute concrete, Con le imprese, Padova vuole essere uno dei protagonisti di questa affascinante sfida per ridisegnare il futuro energetico del nostro pianeta.
With its university, whose constant research group has significant spin-offs, with its industries, Padua want to be one of the leaders in this fascinating challenge to redesign the energetic future of our planet.
Spesso mi chiedo cosa può fare l'amministrazione comunale per sostenere lo sviluppo del proprio territorio.
Often I'm asked what can the mayor do to sustain the development of his own territory.
Rispondo che creare e mantenere le condizioni perché questo territorio ospiti centri di ricerca, scienziati e imprese d'eccellenza coinvolti in progetti di questo livello è per noi un impegno prioritario.
I reply that creating and maintaining the conditions so that the territory hosts research centers, scientists and industries of excellence involved in high-level projects is for us a priority.
Il potenziale che si crea con queste collaborazioni va al di là del singolo progetto di ricerca, ma attiva un circolo virtuoso di scambio di conoscenze che favorisce lo sviluppo di iniziative di eccellenza e attira qui le migliori menti in circolazione.
The potential created by these collaborations goes over the single research project, but also creates a loop of exchange of knowledges which favors the development of initiatives of excellence and entices here the best minds around.
Qui oggi possiamo toccare con mano quanto la ricerca sia importante per il nostro futuro, ma quanto essa abbia delle ricadute importanti già oggi per l'economia e per le imprese, coinvolte nella realizzazione dei componenti necessari.
Here today we can see firsthand how the research is important for a future, but also how it has important spin-offs today already for economy and for industries involved in the realization of the necessary components.
Sono quindi felice di condividere con tutti voi questo giorno, che certamente rimarrà ben impresso nel percorso che porterà alla realizzazione del reattore ITER nel sud della Francia.
So I'm happy to share with all of you this day, which certainly will remain, we will remind in the route to the realization of the ITER reactor in southern France.
Auguro a tutti voi un grande successo. Grazie.
I wish you all the best.
Grazie a lei.
Now I have the pleasure to introduce Dr. Salvatore La Rosa, representing the Italian Ministry of Education, Universities and Research. Please, Dr. La Rosa.
Good morning. We got already a very warm welcome at the very beginning of this inauguration. My speech will not be so choreographic, let's say. So, good morning, dear Director General of the ITER organization, dear representatives of the European Commission and of the European Parliament, dear representatives of the local public authorities, dear President of Consorzio RFX, and ladies and gentlemen. I am proud to be here today celebrating the inauguration of the SPIDER experiment in the new neutral beam test facility connected with the ITER experiment, facility that has, in particular, the scope of enabling scientists to develop the powerful heating systems required for ITER. As you can clearly see, Italy is very much committed to ITER, and the creation of the Consorzio RFX is a concrete result of the commitment taken by Italy and by the Italian Ministry of Education, University and Research that I have the honor to represent here today. I recall the participation of this ministry to the event of December 2015, when this international collaboration celebrated the completion of the facilities and associated infrastructure of the PRIMA project, including the installation of the main scientific components for the neutral beam test facility provided by Japan. Thanks to the excellent work done during these years by Consorzio RFX and the whole international collaboration, an enormous and rapid progress was made, and now we are able to start the SPIDER experiment, the most powerful negative ion source experiment to date, which will enable us to test the extreme conditions of the heating systems required for ITER, providing, after all, essential technological and scientific evidence for its manufacturing. The current framework program for research and innovation of the European Union, Horizon 2020, strongly urges the scientific community to tackle the main societal challenges shared by all European citizens and those elsewhere, among which the theme of secure, clean and efficient energy is considering one of the most pressing challenges we face today. This approach is complemented by an ambitious program in nuclear research, Euratom, which has among its objectives the demonstration of the feasibility of fusion as a power source. The international project ITER is called upon to undertake the scientific challenges of designing, building and operating of facilities which should allow fusion research to progress towards electricity production by around the middle of the century. The successful construction and operation of ITER is on the critical path of the European fusion roadmap, which represents a comprehensive goal-oriented approach to a clean source of energy and has been endorsed by all fusion research stakeholders in Europe. Indeed, fusion is expected to play an important role in Europe's future energy landscape as a virtually inexhaustible, climate-friendly energy source. I am sure that this ambition will be pursued also in the future European Framework Programme 9 for Research and Innovation, Horizon Europe, which I feel will seek to secure funding for continued European participation in the ITER project, aiming at key scientific breakthrough in the development of fusion. For this reason, European Union is working to make available the resources for the Fusion for Energy activities. Horizon Europe, whose proposal has been presented by the European Commission only last week, introduces a number of ambitious innovative elements that the ministry I represent, as well as the ministries that in other EU member states and associated countries are responsible of the research and innovation dossiers, are ready to discuss and develop in detail during the next negotiation with the European Commission. I would like to highlight that among the most relevant innovative components, there is the concept of mission, conceived with the ambition to provide a massive opportunity to increase the impact of European research and innovation, to grasp public imagination, and to make real progress on complex challenges. Missions are expected to be ambitious, even risky, but also realistically feasible, with a clear expected outcome and a clear time frame, long enough to allow research to develop, while at the same time having a delivery date. I strongly believe that, remarkably, the ITER project, in virtue of its mission to achieve a clean and safe energy production, fits well into the definition given to Horizon Europe missions. Since very recently, Italy has a new government. In his speech to the Republic Senate, the Prime Minister, in touching upon the topic of scientific research, stressed the importance of research infrastructures, of the cutting-edge scientific and technological research activities they can perform. In his analysis, he underlined that research infrastructures offer a very favorable condition for the training of excellent researchers, which is also boosted by their capacity to attract foreign excellent scientists. An healthy approach to address the brain drain for their ability of creating strong links with the economic and productive fabric, providing an effective mean for mutual transfer of results and the competences. With no doubt, the Research Center of Consorzio RFX and its activities perfectly fit that profile. In this framework, the Italian government continues to be firmly committed to support Consorzio RFX also through the Ministry of Education, University and Research, which has been actively supporting since 2007 the construction of the facility here in Padua. Let me also underline the willingness of Italy to continue fostering a structuring of the national research system around priorities, also using research infrastructures as a mean and to reinforce its participation to European and international research initiatives when fitting to the national strategy. Indeed, what we are celebrating today is the result of a successful international collaboration of various parties from inside and outside Europe, working together to bring fusion energy a step closer. So let me take this opportunity to extend our sincere gratitude to all partners who have significantly contributed to this project and have made possible the achievement of this important result, which is the fruit of a unique international collaboration in terms of equipment and funding. I would like to extend this gratitude to those involved in the important work carried out by Consorzio RFX, who hosts this facility, and the partners CNR, INFN, and the University of Padua that were entrusted by the ministry I represent with the construction of the facilities and associated infrastructures. I would like to thank also Enea for its important contribution. To finish, let me highlight again that the Italian Ministry of Education, University and Research is very proud to have joined you today in the celebration of this significant step for Prima and ITER. Thank you very much for your attention.
Thank you very much, Dr. La Rosa. Now I kindly ask to come on stage Flavio Zanonato, member of the European Parliament, who has been recently appointed as the Shadow Rapporteur of the European Parliament for the communication by the Commission on the European contribution to a reformed ITER project. Please, Dr. Zanonato.
Prima di tutto voglio ringraziare il professor Francesco Gnesotto per avermi invitato e lo saluto come padrone di casa, come saluto il sindaco, il rettore e tutti i ricercatori tecnici, amministrativi e tutte le autorità che sono presenti. Non le cito perché è un elenco davvero lungo. Voglio solo citare Giorgio Rostagni, il professor Giorgio Rostagni, che è la prima persona che in questa città mi ha spiegato cos'era la fusione nucleare. Ormai sono passati più di 30 anni. Sono passati, dicevo, più di 30 anni, ma ancora adesso mi fa un enorme piacere poter interloquire con lui di questo straordinario esperimento. Sono naturalmente contento di partecipare a questa inaugurazione ed è certo che sarà determinante per il successo del reattore a fusione che è a Cadarache, il progetto, l'esperimento ITER.
Let me first thank Professor Niesotto and all the people who convened here from the European Commission and of course ITER and Fusion for Energy, and particularly Professor Giorgio Rostani, who taught me 30 years ago what fusion is and continue to update me in the next years. I'm sure that I'm happy to participate to the inauguration of this experiment, which will certainly be important for the success of the fusion reactor ITER.
Non c'è dubbio che ITER è una pietra miliare lungo la strada, è una strada lunga verso l'uso pacifico dell'energia da fusione nucleare e siamo impazienti di vederlo entrare in funzione nel 2025. Dopo ci sarà la fase di demo per produrre energia, qui stiamo soltanto parlando di tenere stabile una fusione. Nel frattempo l'Unione Europea sta sviluppando il prossimo programma quadro 2021-2027, Horizon Europe, e il Parlamento Europeo deve esaminare la proposta della Commissione riguardo al contributo per una riforma del progetto ITER e personalmente, come è stato ricordato poco fa dal professor Niesotto, avrò modo di avere un ruolo in questa vicenda perché sono relatore per i socialisti e democratici e vi posso assicurare che mi batterò per il massimo sostegno a questo progetto.
ITER is certainly a lodestone along the path to the peaceful use of nuclear or energy from nuclear fusion, and it will also be developed in the next framework program at European level, Horizon. Of course, I am involved in this because I will be related for this for ITER, and of course I will strive to guarantee the funding.
In questi giorni i giornali hanno molto parlato di questa inaugurazione e di questo esperimento e una delle cose che più frequentemente viene sottolineata è che si tratta di conquistare l'energia delle stelle, di conquistare e di avere sulla Terra l'energia del Sole. In realtà si tratta di qualcosa di molto più complicato, si tratta di controllare questo tipo di energia, perché sotto forma di bomba l'abbiamo già potuta realizzare. Quello che interessa è controllare questa energia in modo di averla a disposizione in modo pacifico e, devo dire, anche senza impatto sull'ambiente, in particolare per quel che riguarda l'effetto serra.
Nuclear fusion is not only the realization of what is normally happening in the stars, but the problem is to control it and to produce energy out of it. Of course, the uncontrolled way, the bomb, has already set off many years ago, but we want to control it in order to produce energy in an environmentally safe way.
Anche nella mitologia greca spesso si fa riferimento al tentativo di conquistare l'energia del Sole. C'è Fetonte che cerca di guidare il carro del papà Apollo, ma non ci riesce perché è molto complicato guidarlo e la sua ambizione non corrispondeva alle sue capacità. C'è il mito di Icaro che ad un certo punto ha pensato di potersi avvicinare al Sole per capirne qualcosa di più, ma le ali di cera si sono sciolte. E infine, qui è andato un po' meglio, c'è il mito di Prometeo che è riuscito a portare agli uomini il fuoco e è stato duramente punito da Giove, anche se poi per fortuna Ercole lo ha salvato.
Since even in Greek mythology they tried to tame energy like the sun. Since Phaeton, who tried to drive his father's Apollo's chariot but failed, and Icarus, who tried to reach the sun unsuccessfully. Fortunately, Prometheus succeeded in taking the fire to the humans, although he was then punished for that, and Hercules had to help him.
Qui oggi siamo nell'unica appendice fuori da Cadarache dell'esperimento ITER, l'unica vera grande appendice. E l'esperimento a cui fra poco assisteremo, probabilmente ha avuto anche delle prove prima, mostrerà come è possibile affrontare uno dei problemi critici della fusione nucleare, il problema del riscaldamento del plasma. E si tratta di un problema enorme e credo che sia davvero un fatto di enorme orgoglio per l'Italia e per la città di Padova, come ci ha ricordato il sindaco, avere questo esperimento in questa sede, perché consente di avere una quantità di ricercatori e di scienziati davvero straordinaria.
This laboratory is the only ITER appendix which is not in Katahash. This is related to the heating system for ITER, which is one of the main problems to start the fusion reactions. We are happy, as the mayor said, we are proud to host it in Padova.
Quindi mi congratulo con il team del Consorzio RFX, con l'Agenzia Europea per Fusion for Energy, con l'Agenzia Indiana, anche questo è un segnale importante per la pace, con ITER Organization, per aver raggiunto questo grande obiettivo e davvero tantissimi auguri per un miglior successo di questo esperimento.
I congratulate with Fusion for Energy, with ITER India, with ITER itself for this endeavor, and I wish you all success.
Now I have the pleasure to call on stage Dr. Carles de Deu i Fontcuberta, the representative of the DG Energy of the European Commission. Please, Dr. de Deu.
Dear Italian representatives, member of the European Parliament, Director General of the ITER organization and Director of Fusion for Energy, representative of the laboratories in Europe, dear all, it's really a pleasure to be here today. It's the second time I am in Padova. The first time it was 8 years ago when I had the opportunity to organize a meeting with our colleagues, Japanese colleagues, under the broader approach agreement. At that time, I already understood how committed is Italy with fusion and how RFX is committed to the project. So thank you for that and continue like that. I would like to say today that SPIDER is a major international achievement. I would like to congratulate the ITER organization and Fusion for Energy and RFX for the work that they have delivered in achieving this major milestone. This milestone has not been possible only with their effort, but also with the effort of our international partners, in particular Japan and India. I would like also to remind today that the European laboratories in Europe have been a major step in achieving this milestone today, this facility here, in particular Germany and the United Kingdom. Thank you for your efforts. The Commission is also very happy to see how industry is participating in the project. We understand that industry is a major stakeholder for ITER. It's not just in terms of what the industry can deliver to the project, but also what the industry can receive from the project. We understand that the industry can benefit from innovation, from growth, and we wish that industry gets involved in all the process to complete the ITER project. Today is, as I said, is a major milestone for ITER, for Italy and Padova. We believe that the NTBF will deliver a major output for our fusion efforts and ITER. You know that the European Commission is supporting ITER since the beginning. As you know, since 2016, when the new baseline was adopted, the Commission adopted also a communication afterwards in 2017, which was called a communication on an ITER reform project. The objective of this communication was to support the new path of the project, the new schedule, and the new cost estimates. The idea was to submit it to the Council of the Ministers of the European Union and to the Parliament, asking them to have the support that the project needs. I am very pleased to announce today that on the 12th of April, the Council of Ministers approved and endorsed our communication, giving a major signal to our international partners that they are supporting the project as well. So the European Union gave a major signal saying that we, Europe, we are with ITER, we are with Italy, and RFX here today. After that, on the 2nd of May, you may be aware that the Commission has published the new financial perspective. This is a major initiative that covers the whole political initiative of the European Union for the next financing period. This will be from 2021 to 2027. In this financial perspective, the Commission has introduced not only a budget for energy or for regional effort or for innovation, but also a specific budget for ITER, following our communication in June 2017. It is now time to discuss with the Member States to make sure that the Member States and the Parliament as well continues supporting the ITER project and approves also this budget for the future. Last week, and I'm just wanted to finalize by saying that last week the Commission also adopted a proposal to fund the activities of Fusion for Energy. The budget for Fusion for Energy was presented, and with this proposal what we are trying to do is to make sure that in the future the European contribution to ITER and other activities like here in the NTBF will be made. Our effort now will be to discuss with the members of the Parliament and to discuss with the Council to make sure that the money is there. Let me finalize by thanking all of you for this major achievement today, and I wish you the best luck, in particular to the scientists and researchers that will be here to make the experiments. So best luck, all of you. And this will be a major signal. If we succeed on this, this will be a major signal for the success of ITER. Thank you very much. Tanti auguri. Grazie.
I kindly ask to come on stage Dr. Elisa De Berti, Councillor for Public Works, Infrastructures and Transportation of the Veneto region. Thank you.
Buongiorno a tutti. Oggi io sono qui per portare i saluti al Consorzio e a tutti voi da parte del Governatore Luca Zaia.
Hello everybody, I'm here today to give you the greetings on behalf of Governor Luca Zaia.
È un onore e un piacere essere presenti a testimonianza di un importantissimo evento non solo per la nazione Italia ma anche per Regione Veneto e la provincia di Padova.
It's an honor and a pleasure to witness this event, which is very important not only for Italy but also for Veneto region.
Questo esperimento, frutto di un connubio tra ricerca, formazione e innovazione, dà prestigio al Consorzio sicuramente, ma dà prestigio anche a tutte le aziende e a tutto il comparto economico e produttivo della Regione Veneto.
This event is a collaboration and gives importance to the Consorzio RFX, of course, but also to Veneto region and the industries therein.
Un'eccellenza a livello mondiale, e questo succede in Veneto. Il Veneto spesso viene accostato alla parola eccellenza perché riesce spesso e volentieri a distinguersi in vari settori, ma questo avviene anche grazie alle proprie aziende e grazie agli enti che con i risultati raggiunti oggi veramente rendono grande la nostra regione.
An excellence in Veneto which often distinguishes itself because of the high level of the industries and the people.
Complimenti ai ricercatori, complimenti per il risultato raggiunto, con l'auspicio che questo sia uno solo dei tanti risultati e delle tante soddisfazioni che il Consorzio, insieme a tutti i suoi partner, regalerà all'Italia.
Many compliments to the researchers, but also a wish that this is only the first step towards much better successes.
Ringrazio per l'invito il Presidente e auguro a tutti una buona partecipazione all'esperimento. Grazie.
I thank the President for the invitation and I wish you all the best for the experiments.
Grazie molto. Grazie. Buon ritorno. And now it's time to come closer to science and technology. So, Professor Bernard Bigot, Director General of ITER, please come on the stage.
President Gnesotto, dear and distinguished Italian and European authorities, dear colleagues from Consorzio RFX, the ITER India, and all the domestic agencies which are present today, as well as the ITER organization staff and authorities, dear friends, ladies and gentlemen. It's my real pleasure and a great honor to be here today and to participate in the final countdown for the operation of SPIDER, the most powerful negative ion beam source ever built in the world. Where else but here in Padua would we want to celebrate such a technological breakthrough? Padua, the workshop and home to figures like Nicolaus Copernicus and Galileo Galilei, intellectual giants who, I believe, we can all agree, changed the cultural and scientific history of humanity. Fusion energy, too, has the potential to change the course of mankind, and ITER will pave the way as the next step in the fusion roadmap for all ITER members. No doubt that we still have to overcome many challenges to reproduce the energy that powers the sun and the star down here on Earth in a sustainable and economical way. But we are getting closer every day. One of the big challenges for tokamak fusion is to create the temperature that will force the hydrogen atoms to fuse inside the ITER vacuum chamber. Incredible temperature indeed, 150 million degrees, 10 times hotter than the core of the sun, are necessary for this to happen. Beyond the plasma current induced by the magnetic field of the tokamak magnetic cages, we rely on a set of three sophisticated heating systems to reach and keep the temperature, amongst which the neutral beam injectors are the most powerful one. Neutral beam technologies overall is not new. Neutral beam are roundly used for plasma heating in fusion devices all around the world. But the size of ITER called for much thicker particle beams and much faster individual particles in order to reach deep into the core of the plasma. To achieve this, we decided to go for the new technology breakthrough and to the negative ion instead of positive ion beam. SPIDER, the beautiful creature just behind me, which will come soon to life, will help to develop this new technology and provide the necessary extraordinary potential we need. But as impressive SPIDER may be, it is much more than just a science and technology ingenuity. It is also an example of exceptional international collaboration. Italy and Consorzio RFX has provided the facility and a large contribution toward the personnel. Fusion for Energy, the European Domestic Agency, organized organization that take is in the shape of the European contribution to ITER has financed most of the component building on the expertise of European industry and resource organization. ITER India, as well as ITER Japan, managing India's and Japanese contribution to ITER, has also provided a critical component for the development of the neutral beam test facility. I am very pleased to say that I want to sincerely congratulate all of you assembled here today on this important occasion. It is only thanks to you, professionalism and commitment, that we can celebrate this important milestone today, which brings ITER another step closer to its important goal. But remember, ITER is SPIDER is just one critical step for the completion of the mission of the neutral beam test facility. Thanks, there is a lot to do still in order to achieve our goal and to optimize the design of the true neutral beam injectors which will be needed for ITER. It is why it is so important that we complete this mission and enlarge the agreement we have now between the RFX and the IO. So, thank you to all of you. Let's come now to the event of the day, which is a SPIDER start, and I hope that very soon we will be able to have this machine turning on. Thank you very much for your attention.
The European contribution to ITER is provided by Fusion for Energy, and we have the pleasure to have today with us Dr. Johannes Schwemmer, the Director and CEO of Fusion for Energy. Please.
Thank you very much. Dear President Niesotto, dear Francesco, dear Giorgio Rostani, who has started this very much in the early days, distinguished excellencies, dear colleagues from RFX, from ITER-IO, the ITER parties, and the European Commission, dear company representatives, and especially dear Fusion for Energy staff. It gives me a great pleasure to be here with you today to officially inaugurate SPIDER. You've heard it's the biggest negative ion source in the world, but it is also the first piece of ITER to come to operations. And this is a very important event after all the times ITER has gone through. So the theme of today is really, again, bringing the power of the sun to Earth. And you may have realized that if you pronounce SPIDER a bit more harshly, SPIDER, ITER is inside the word SPIDER. So it was clear from the beginning, we want to build the first piece of ITER. So today SPIDER comes to light. And the know-how that we will extract from SPIDER will feed into ITER. What happens in this facility matters enormously to achieve the extremely high temperatures that we need for the ITER plasma, as Bernard Bigot has just explained. Consorzio RFX is the host of a center of excellence putting at our disposal the expertise to develop neutral beam injectors. Europe, in particular Italy, together with India, Japan, and the ITER organization have worked together to build this facility, procure and manufacture its components, and to set it to operations. I acknowledge the excellent work carried out in the European fusion laboratories for decades, contributing to the developing of the neutral beam systems. For instance, the Institute for Plasma Physics in Garching, the Cullen Center of Fusion Energy, and the CEA. The unwavering support of ENEA, of Consorzio RFX, of INFN, the University of Padova, and the CNR has also been instrumental at securing the level playing field for Italy's fusion community. Talking about the roles, last not least, let me say some words about the role of fusion for energy, which is pivotal in linking ITER with the European science and the European industry. This is a very complex environment, especially from a legal and contractual point of view. It is at the interaction of the initial ITER agreement, the European public procurement laws and procedures, and the constraints of the ITER projects, where ITER-IO imposes engineering standards, quality, schedule, and design. So our industrial and research partners sometimes feel that this world is a bit too complicated, and they would like it to be more simple. I assure you that our Fusion for Energy people feel the same. However, we are bound by these regulations, and as you see, it is possible to build something in this environment. This is how you all together completed SPIDER, with intense cooperation. As most of you know, the ITER project had stalled some years ago, facing these and other cultural and structural issues. But since more than 3 years, this has changed. ITER is progressing, and SPIDER is a wonderful example of that. The rewards are attractive for all partners. For SPIDER alone, all parties have invested more than 62 million euros and involved at least 100 companies, the majority of them small in size and mainly in Europe, a large number in Italy. Later on, we will hear how SPIDER built a bridge between research and business, and how to many it opened the door to the big science market. Let us take a moment to look at our collective achievement and congratulate all parties. The technical teams around the world, our industrial parties who were involved in this remarkable project, and, if you allow me, a special thanks to my Fusion for Energy staff for working relentlessly to honor Europe's commitment. Thank you. Today, we switch on SPIDER for the first time. From this moment, the ITER neutral beam test facility will contribute to bringing us closer to the electrical power of fusion energy. But let's not forget, after the game is before the game. Now SPIDER has first plasma, and together with the same enthusiasm and excellent cooperation, we will then build Mythica. Thank you.
Finally, I kindly ask to come on stage Dr. Chandramouli Rotti, representing the Indian Domestic Energy.
Distinguished guests and the host Consorzio RFX. I have been entrusted with the honor of presenting words of Shishir Deshpande, Project Director of ITER India. Following are his words. Dear all, I thank you for inviting me on this auspicious occasion to celebrate the start of a new phase for NVTF. Today marks the start of the operational phase on SPIDER testbed. I am very sorry that I cannot be there in person for taking part in this important milestone on the path to demonstrating ITER-sized beam sources. I consider that realization of ITER-neutral beams is the most challenging endeavor, not only for the reason that its components are technology intensive and are to be built with demanding requirements, but also for the reason that their performance is first of their kind. Full-scale prototype experiments are a must. And today, we are witnessing NBTF program transitioning from procurement phase to the operational phase. It is the first time that an ion source of ITER dimensions, which is the largest ion source ever to be built, will operate and perform to produce the beams relevant to ITER. The experience gained during the manufacturing of Spider testbed components paves the path to delivering ITER components compliant with stringent quality and safety requirements. It is a moment of pride for me to extend my heartfelt congratulations to the team of Consorzio RFX, ITER, and the domestic agencies who have strived tirelessly to present to us the commissioned facility, the Spider, an experiment that leads to the development of one of the most important heating systems of the ITER machine, allowing fusion temperatures to be attained. The Indian Domestic Agency cherishes its association with NBTF. The technical teams have successfully met all the challenges that have been posed due to the technical complexities of the components. It was an opportunity for us to ensure that manufacturing meets the requirements of ITER deliveries. In fact, the NBTF components were among the first deliverables from the Indian Domestic Agency for ITER. The very fact that Spider will now start operating is a testament to exemplary collaboration not only amongst the NBTF stakeholders, ITER, the European Domestic Agency, the Indian Domestic Agency, the Japanese Domestic Agency, and the host organization, Consorzio RFX, but also between each of the stakeholders and the industries that have associated with them. I thank our industrial collaborators in India and in Europe for having accomplished the task so well. Their learning and experience is of benefit for ITER. I'm confident that this NB team shall establish the desired objectives of Spider and continue to reap the benefits of the framework of collaboration they have established, which draws upon the best of the global expertise. I extend my congratulations to the team and reiterate the pride of Indian Domestic Agency to be part of this exciting challenge. Thank you very much.
Thank you very much. So I thank all authorities for their kind contributions, and I leave the floor to Maria Teresa. Thanks.
Thank you, Francesco. So, ladies and gentlemen, today we'll be hearing a lot and talking also a lot about fusion science and technology. But all this wouldn't have been possible without the large contribution of industry. So now this is why I hand the floor over to my colleagues, Aris Apollonatos from Fusion for Energy.
Hello, everyone. It's great to be here. If we look back into the speeches that we heard earlier this morning, there is one key word that stands out: partnership. It's a word that shouldn't be taken lightly, because nowadays, partnership should not be taken for granted. But science has this incredible capacity to bring people together regardless of the political differences or regardless of the cumulative gains that they may have in the end. Because science has the capacity to bring us together for the common good. Spider, just like ITER, following exactly the same way of thinking, has brought together scientists from around the world, business communities from around the world, and has made them work together. When we tried to put together this session, we thought it's of fundamental importance to talk about the way that these two communities have worked together, learned from one another, generated jobs, and how they see ITER in the long term. So we put together a panel bringing together some of the companies that have represented the work that you see around, in order to hear from them, from the range of technologies that they bring together, their story, Please welcome on stage, one by one, Charles-Antoine Goffin from Thales. Giuseppe Tadia from Ocem. Fabien Sirotti from Angelatoni Test Technologies. Christian Eckhart from PVA Tepla. And Michele Tamagnone from Delta T Impianti. You may take a seat. Thank you for joining us. And for those who don't know, we've spoken previously on the phone with all the participants, but now it's actually the first time that we are sitting together to have a chat, just like we did on the phone. Perhaps to break the ice, the first thing we should do is hear from all of you how your company contributed to this project. So maybe I can start with Charles-Antoine, and then I'll give the floor to Giuseppe.
Okay, thank you, Iris. So I represent Thales, and for our contribution to SPIDER, we formed a consortium together with Checom, Zanon, and Galvanotti, and we were in charge of producing many of the components, integration, assembly, also of the hydraulic parts, and up until the delivery here in Padova.
Now, you represent perhaps one of the biggest companies that we have currently on the panel, because what you should know is that SPIDER has been a project that brought together also many small, medium enterprises from all around Europe. How many subcontractors did you have, more or less?
Well, we had, I think, up to 60.
Up to 60 companies that worked with you.
Subcontractors, and that was the big challenge.
Excellent.
On our part.
Giuseppe, what about your company and the way that you contributed?
Thank you. My company, Ocem, was born in 1943 in Bologna. We restarted in 2011 with 25 people, and now we are about 70 people in staff for a total turnover of about 21 million. Regarding our involvement in this big project, we are responsible for the system that is called ISEPS, that means Ion Source and Extraction Grid Power Supply System. In a few words, it is the complex power electronic systems that feeds with high voltage, high current, radio frequency, and of the control system that manages all the stuff that is necessary to supply the ion sources for SPIDER, then for Mythica, and also for ITER, neutral beam injectors.
Thank you. Fabien, your company also played an important role in setting up SPIDER.
Yes, our company, TT Angelatoni Test Technology, is a company that produces equipment for environmental testing by simulating temperature, humidity, vacuum, high vacuum, and rain test for environmental tests. Our main customers are work in the field of aerospace, automotive, defense, and also defense. Our contribution in SPIDER, we get a contract in 2012 together with our subcontractor Rivoira. We design, produce, and install and test a vacuum system and gas storage, distribution, and injection systems. In other words, we installed a system to make a vacuum in SPIDER and to inject gas, hydrogen, and deuterium in a SPIDER vessel.
Thank you. Now, Christian, in your case, PVA Tepla worked directly with ITER India. So maybe you'd like to explain how you worked with another of the ITER parties, being a European company also.
Thank you. So I'm representing PVA Tepla here.
and we are manufacturing high-tech components and projects for various customers in the world. And part of this is also in the division of fusion research and accelerator research. And we are especially proud to have contributed to this beautiful spider project here.
Great. Michele, we end with you the tour de table, where you can tell us how Delta Team Impianti contributed to the facility that we are.
Thank you. Yes. Good morning, everybody. We built for the neutral beam test facility the cooling system. It means the mechanical plants and the piping that cools down by means of water fluid the experiments, both Spider and Mythica, when it will be ready for operation. Our company is specialized in such kind of systems, meaning industrial cooling and piping in general, also for district heating systems. And we built this kind of plant and the whole water fluid cycle system as well for the Spider facility.
Thank you. Now I'd like us to move the discussion perhaps to the challenges that we faced in Spider. Talking to a number of you, certain keywords came without knowing that you all repeated the same. A number of interfaces, the complexity of the project, or the instinct for adaptability, even for big players like Thales. Charles-Antoine, would you like to expand a bit on the challenges that you faced?
First challenge was to form a consortium with such different companies, such as Thales and some medium or smaller size. And that was a true success. The true challenge is when you have more than 60 subcontractors and you need to make sure that everything comes at the right time, at the right place. And the law of probability will tell you that when you have 60 of them, there will be some delays. And so you have to adapt very quickly and to put all the resources to catch up as much as possible with the time. That was the real challenge for us.
Okay. Giuseppe, when I spoke to you, you mentioned the multiple interfaces that you faced in this project. If you would like to tell us a bit more.
Yes, we are in the business of big physics from the beginning. But in this opportunity, what was really new for us was to have not a single counterpart, but having several entities. And we have to learn to cope with the needs and what is necessary to agree with the different partners, starting from Fusion for Energy, that it's our customer at the end, but many other entities, important entities, are involved. Another point, obviously, is the technical level of what we have to supply. Very ambitious, very challenging. Not only in terms of performances, but also in terms of management, organization, quality assurance, supplier management, this kind of stuff. Very challenging, also very interesting, and helped us to grow in a right way.
So I keep from your intervention the fact that there is an unprecedented level of rigor and tracking and follow-up that needed to happen, regardless of the fact that we're in a research test facility. But one of you actually brought in the discussion that there was also a degree of improvisation and adapting along the way because certain things were not fully finalized. Michele, you brought this point up, and you jokingly also said one thing we take is question researchers from time to time.
Yes. Yes, this was, I think, the main challenge we had faced. The capability to be very flexible and to follow the requirements, because when you start a project like this one, you think and you hope that researchers or the client has a precise idea from the beginning of what they are going to do. But of course, maybe the focus is more, the attention of the other side, I mean the client, is more focused on the experiment, which is the more complex part, not on the accessories like our plant, which is a cooling plant. But of course, this means that we have to be capable, to be adaptable, and in order to follow requirements that evolve when along the project evolution and together with the design and the construction then.
Now, Fabien, in your case, you were confronted with the titanic task not only of the technical specs, but also of the volume of documentation that you were confronted with, yes, which was a one-of-a-kind experience.
Yes, it's right. So for this project, we made a lot of calculation at the beginning, and it was a challenge for us, in particular for the safety matter, since we are inject hydrogen in a closed volume. And we had for this project an unexpected volume of documentation to be provided. Generally, in our standard business, we share with our customer less than 10 documents, official documents. For this project, we have submitted in preliminary design and detailed design approximately 80 documents. It's different from our standard business.
Now, Christian, going to you. In your conversation, you mentioned that what you found unprecedented was the fact that this is almost like a proper functioning, full-scale operational facility, regardless of the fact that this is research. And this is something that impressed you with the level of clarity, thoroughness, and rigor that everything had to be set up. How was this challenging for your contribution to SPIDER?
Well, if you consider that SPIDER is now the most powerful ion source in the world, and we manufactured the beam dump where all this energy then needs to be deposited, we also had to follow the complete qualification standards. And this is where I think ITER India was very focused on having us follow the complete ITER standards required later on. So we made a very good progress on the qualification and documentation issues, and we're in the end able to provide a fully functional component that is installed and that we were going to see working quite soon. It was interesting to see a component so much larger than what we typically manufacture. So the scaling process was there involved. But in the end, we found that the scaling wasn't that difficult a task. It's more the documentation, the qualification, and formalism process that we need to go through, as Director Schwemmer already mentioned, for ITER components. This is where especially small, medium companies need to adapt.
So it has been a learning curve for all of us and years of work in pulling everything together, but there have also been benefits from this involvement. And I think it would be interesting to hear from each and every one of you your version of the benefits. You come from different companies with different areas of expertise, different in size, different exposure to the European market. And from what you said, there were many different bits and pieces that you can collect along the way. Perhaps I can start with Giuseppe, and you can tell us how OCEM specifically was benefiting from its involvement.
Yes, it was a big opportunity to improve our knowledge. Technically, this is obvious, challenging but obvious, but also in terms of management and particularly project management. And for this, Fusion for Energy for us was very helpful, a very good school, teacher, let me say this. Other important parts regards the motivation of our people. It's very interesting for each of our staff to be involved in this kind of project. Long-term business opportunity for us, this kind of contract is one of the ones with the longest duration. And okay, for the business point of view, it's interesting. And also visibility that these opportunities bring to our company.
Thank you. Charles-Antoine, in our interaction, one of the points you raised, which is important, is the fact that your company is also interested in projects that have R&D at the core of the business. And would you like to expand on this and why this is important?
So in Thales, I'm in charge of the electronic tubes business for defense, industry, science, and telecom, and the big science. And for us, the big science activity is absolutely key to attract the best talents, because for all this activity, we are looking for excellency everywhere. So of course, ITER, in all its forms, because we work also with the ITER India, for example, ITER by itself is a great opportunity, but even more, it's a strategic importance for us, because it allows us to bring the best talents, which are key for all our activities in electronic tubes.
Thank you. Now, I'm hearing the word big science, and Christian, you have actually explained how big science projects have opened a new market for your company. And if I'm not mistaken, you've also attended the big science forum that was taking place a couple of months ago. If you'd like to expand on that.
Well, what I believe is that especially forums like ITER, like the Big Science Forum, those platforms enable smaller and medium companies to get in early contact with other larger players probably, and play out their key strength. So there are a lot of things that not any company can do alone. I mean, Thales mentioned having 60 subcontractors. No one of those subcontractors could work for ITER alone, but together with larger firms, larger companies, consortia, organizations, there's a lot of business opportunity through research projects, especially if they are very large. Because if they are smaller, one company could do them alone. But the large one, they only work in collaboration.
Fabienne, in your case, when we spoke, you mentioned the fact that you amplified your supply chain and you were able to connect with others.
Yes, one of the main benefits for this we get with the opportunity to work for Spider project was to increase our supply chain. In fact, now we are collaborating with an Italian company to produce a big space simulator. It's one of our equipment that we produce very often. Other benefits with Spider, we get the opportunity to know other players and get them to know us. In fact, now we are starting more collaboration with the other company, not only Italian company, but also other foreign company.
So I get the sense that there is learning and there is potential as you build partnerships by participating in the project. Yeah. But you've also improved a lot of your standards and your project management skills. For example, Michele, you were talking about this.
Yes, as Giuseppe told, for us it was quite similar. The project management of this contract was tough, but it was a kind of gain of expertise to work with experienced people established in this field, so fusion projects, and close to them, and to manage and coordinate for this common target to make the experiment work, or let's say to allow the researchers to perform experiments with our systems. It was a kind of school for us in terms of management. Then we can say that of course it was the first contract for a fusion project. So it was for us a great opportunity to become more familiar with the fusion communities. So we discovered Spider and Mythica, of course, and DDT as well in Italy, and ITER. And we hope, we would like to carry forward on this area of work that we hope will grow in size in the next future.
Now, you bring me to the next theme, which is fusion. A number of you have worked before in fusion projects, but some of you haven't. And one of the revolutionary things that ITER has been doing, and subsequent smaller projects, is to show that there are business opportunities and paving a market for this direction. I'd like to hear your thoughts. Charlotte, starting with you.
Well, yes, we are working on the three means of fusion for ITER. Of course, Spider. We are also working with ITER India for the ionic heating, and also for the electronic heating, we are providing some gyrotrons. And of course, for us, ITER is a big business opportunity with a true long-term opportunity, even if sometimes we need to see more clearer in the timeline, because I know there's a lot of difficulty of international discussion on this, but of course it's an opportunity, a global opportunity for us.
Now, Giuseppe, you're one of the people in the panel that has had a long track career in this area, and you've been in different projects, if you'd like to expand.
Yes, we were involved in several fusion projects practically from the beginning. Also, we worked on RFX in the plasma physics experiment here in Padua. This means that for us, it was not really a new market, new sector, but in any case, the activity on Spider bring us to develop new solutions, in particular new control equipment that we are now using also in different markets, for example, in the particle accelerators.
Now, if I can bring Christian on board, because you've been working with ITER India, but you have some prehistory in the fusion as a company, if understood well, from the initial stage, although your involvement has not been so direct. If you would like to share some thoughts on that.
Yes, of course. We as a company have been working for fusion, one could say, from the early beginnings. We were involved in a few projects at IPP Garching and at the Column Center at JET. I believe it's true to say that we built the very first neutral beam injection part that was used for those components, so the very small brother of the large spider source we're now going to inaugurate today.
Michele, in your case, the cooling plant, but you've been doing cooling plants before. How was fusion, for example, different in your case?
Okay. About the piping, it's exactly the same. I mean, the concept is exactly the same. Is the target, so the result is different. So you have maybe more constraints that are not standard constraints. So you have to, even starting from the design phase, you have to be very, pay attention, be very careful in the check of the requirements, because they are not standard requirements as for example, cooling and ventilation of industrial buildings that we usually do.
And let me conclude with Fabienne. Your company's involvement in fusion, was this a first, or is this the beginning of a long-term relationship?
Spider is the first, but with this contact we also have the furniture for Mythica that are in progress. And we got other two contacts with Fusion for Energy for a preliminary stage. And of course, we are looking for other business opportunities, also making other tender offer and we are looking for new business opportunities.
And I'm sure there will be in future. If I can just close with one thought, the fact that we're all extremely excited for the next phase of the operation, where we will be seeing plasma in Spider shortly. I think we all have a certain degree of enthusiasm to see all this work of the last 10 years coming together. And with this, I'd like to close our panel, thank our participants, and thank the audience for the attention, and bring Sabina Griffith on the floor for the exciting part now, which is the plasma operation. Thank you. I think we need to move. You can take water with you if you want.
So, now, we are getting closer to the climax of today. My name is Sabina Griffith from the ITER organization, and we have to clear the stage and do the setup for the first plasma. Meanwhile, we want to show you a small, short film, 3 minutes, explaining what SPIDER is and how this works. And then I promise we will launch the first plasma of the machine that is already pumping behind this concrete wall. It's waiting for us. So please start the video, and then we will be ready.
ITER is an experiment to verify technical and scientific feasibility of fusion as an energy source. The ITER plasma will reach 150 million degrees, but there are still many uncertainties on performance of a neutral beam injector suitable for heating the ITER plasma.
The plasma is 150 million degrees. It's hotter than the core of the sun. But we need those temperatures to get the fusion reaction to happen. And the only way we can get those temperatures is by the use of one of the most powerful systems for heating at ITER, which is the neutral beam injection system. For the first time, we're going to use negative ions, not positive ions. So these particles will start as negative ions, they'll be neutralized and then shot into the center of the plasma. When they're neutral, they can go into the center and they won't be perturbed by the magnetic fields that are keeping this whole plasma contained within the machine. So how do we make the negative ions? Well, we basically heat up a gas inside a source. And once we heat the gas, we make a plasma. And the plasma has many different charged particles inside. By actually injecting cesium in a vapor into the source, it covers all of the area of the source. And on this cesiated surface now, we can make the neutrals turn into negative ions, and then we extract them out. The ion source that we have at SPIDER does exactly this. It's the largest ion source available in the world today. It has been manufactured by our colleagues together, looking at the design and the functionality and the manufacturing with all of the European labs and the European industries. And we have put it together into the SPIDER test facility that we are inaugurating today.
With the establishment of the ITER Neutral Beam Test Facility in Padua, a new center of excellence in science and fusion has been established within Europe. SPIDER has brought together the science and business community. They learn from each other, they work together, they innovated, and they discovered new market. For SPIDER, 62 million euro have been awarded in contracts by the parties to about 100 companies, most of them small, medium-sized. SPIDER is the successful result of an international collaboration, and in a sense it is like a mini ITER. Multidisciplinary technologies, lots of interfaces, parties working together with a common objective. We at Fusion for Energy are proud to have played an important role in the establishment of this experiment. Now operation will start and will produce essential results to get closer to fusion.
The inauguration is not the end point, it's the starting point of the experiments, but I'm fully confident of the team, and I'm also confident that at the end the results will be achieved with hard work, but they will be achieved. And it will have its neutral beam injector.
Okay, you see, it's all easy. It just takes a video to do that. Now, we come to the most important moment of today. I would like to ask all the speakers of this morning, plus the teams, the technical people, meaning Vanni, Chandra, Tuyu, and a lady, Deirdre, finally, to come on stage and to help Mr. Bigot to press the button and to launch the first plasma of Spider. Please come and join me here on stage. Mr. Pizzotto, please come. Mr. Bigot, if you want to stay here, you have the honor. And if all the rest of you, if you want to stand around. Deirdre, come on in. So, I now call my colleague Maria in the control room. Here we are.
Okay, I'm lucky today. I'm in the core of the experiment, directly here in the control room, where everything is ready to launch the procedure. And let me just please introduce you to the two engineers on charge today. And
Luca Grando, Marco Boldrin,
okay.
Mauro Breda.
Marco Bigi.
Okay, the scientists and engineers who will be on duty here today. And let me please introduce now to Pier Giorgio Sonato, Director of RFX, to whom I ask, what are we going to see now and what's happening now?
Okay, thank you. Thank you, Maria Teresa. And now we are trying to make one experiment to repeat something that we succeeded to reach last week. Essentially, in the plasma source, we will see a light that appears on 1,280 holes. That is this light, the evidence of the fact that the plasma is generated. From this plasma, in the next month, we will operate to extract negative ions from the biggest negative ion source never built in the world. Therefore, now I am asking to the team here if they are ready for the countdown. Then I will leave the microphone to my colleague for the countdown. Are you ready for this experiment?
Okay, so
now
let me just explain to Mr. Bigot what's happening. So as soon as you are ready, you start the countdown. We count down to 5, and after 5, you put your hands on there, and they will press the button. And then it will take 4 or 5 seconds until we see the first plasma shot on the big screen here behind us. So please wait. Just take it off. Just wait. Okay, we are ready. We are ready when you are.
Okay, so we are ready to...
Okay. Minus. Countdown. Minus 5, 4, 3, 2, 1. Pulse on.
Look here. This is it.
Okay, it's done. We had a plasma. You have seen the plasma light diagnostics, DRF, and the bias applied to the plasma grid. This has been approximately 10 seconds or something more than 10 seconds of stationary plasma. And I want to say at the end of this that in ITER, this is the first plasma produced in one part of ITER. It's not yet in the tokamak. We hope to see this as soon as scheduled, but this now is a plasma created in a plasma in ITER system. Thank you very much.
Well, bravo. So while I will give the floor, while I have the technical people here, what does this moment mean to you? I see tears in her eyes, so this is a very emotional moment, I guess, right?
Not just my eyes. I think if you look around, you'll find that in all of our eyes. This is a big day.
Sorry.
This is a big day for all of us. We all played a big part in this.
Vani, you want to say something? Is this?
So, I'm emotionated, sorry, but this is the result of a long, strong work with a very good team, international team, and this is very nice for me today. It's a big milestone. It's just to start the next step. We are thinking to the next.
As we heard today, after the game is before the game. Chandra.
Yeah, this is the moment that all of us, we were looking forward to see this operation phase. Up till now, it was only the design and procurement. The operation was very nice, and it's really good for all of us.
Yeah, this is a very big moment for everybody, and I think that it can only be possible through cooperation. Cooperation, I think, is the key word for Spider, for Mythica, but I guess for ITER as well.
Mr. Bigot.
Yes, I am really proud to see this achievement. As you know, we are committed to deliver, and the most important for us is to keep the trust of all the stakeholders, and when we complete on time, on specification and schedule, is the best for the project. Thanks to all of you.
Good. Ms. Remmer, and then we give the floor.
I'm really impressed how these very different people got together to become such a strong team, to overcome difficulties together. You really did an excellent job, and this will enable you to do much more.
Okay.
So now, I told you that we have director of the University of Padova, Professor Rosario Rizzuto, who is representing now all the partners of Consorzio RFX. So I would like to ask him what is the commitment of the university in particular, of course, for the future of this research, in particular the future of fusion.
First of all, let me say that I'm really honored and excited to be here in the first moment of an experiment. As a scientist myself, I know that planning and fundraising takes a lot of time, and the more complex is the experiment, the more it takes time. But there is one magic moment in science, which is when experiment starts. And we were here today. We were here at the beginning of the experiment, and let me say, as director of the University of Galileo, I think that it's a special pleasure to be here in this moment. The commitment continues. Let me say, Flavio Zanonato mentioned Giorgio Rostagni, and this is an opportunity to thank him again and to remember that science arrives through a long path. So if we are here today and we are here as university, is because the Institute of Electrical Engineering in the 60s thought about hot plasmas and experiments in hot plasma. And in the 90s, then with ENEA, NFN, CNR, the RFX consortium started to operate and started to operate so well. So we are at the moment of a path. In this path, the university took part, is taking part, and will continue to take part through the people that are working. Let me thank all the scientists, the administratives, the technicians, that allow the work to be done, through the training of the young people. Let me remind you that we have courses in plasma physics, courses in fusion science. We have an international PhD program entirely dedicated to fusion science. This commitment will continue because this is a strategic investment of our university. Let me also say, and I would like to conclude with this notion, that I thank the colleagues of RFX here in Padova, but I'm really proud and glad of this international cooperation. And let me say that also in this case, science has a role, not only because it does experiment, but because it says through the facts that international cooperation is a strong element in advancement and in success. It's not competition between nations, but it is cooperation with nations that allows great successes to be taken. So I conclude to saying that 5 centuries ago, Galileo in our university was looking at the stars and was doing it because he was in a successful scientific environment. I think he would be proud that 5 centuries after, we are participating in taking a little bit of what happens in the stars for the benefit of science, for the benefit of the world, into a real scientific success. So congratulations to everybody.
So, while all the engineers and scientists gather here and still upstairs can breathe through and relax a little bit, their deed is done. Again, chapeau to all of you. We will clear the stage and give the floor over to the artists and dancers and musicians and enjoy the rest of the morning and the afternoon. Thank you very much. Okay, done. So, we will close the stage, but there is one last thing to do. We want to ask all the actors today to come once more on stage for the final group photo that will go around the world this afternoon. Please come and join us for the group photo, and then you're free to go outside and breathe and have a coffee or something to drink. Please come on stage, all the actors that played a role here today. Oops. Yes. Do you want them to move together? It's okay, or do you want to see the spider in the middle? Maria Teresa, can you translate? Yeah. Would it be possible, Mr. Bigot, Mr. Chaumet, to leave a little gap so that we can see the machine in between? Yeah, maybe you can shape a V so that spider's in the middle. Okay. Okay.
We're going to get the picture in any case, right? So I'm going to do it with the iPhone. We're going to get it, I said, from afterwards.
It's Maria Giovanna who coordinates it.
Because from
Okay, this mission is completed. Thank you very much. Thank you.